Bismillahirrahmanirrahim. I thought I would do some examples of some proofs for triangle. So in each of these 6 questions, we're asked to prove that the triangles are congruent. If you recall, we had learned 5 ways of proving triangles congruent: side, 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 angle, side, angle, and angle, angle, side, and hypotenuse leg. And we had suggested that these were theorems and these were postulates that we had learned. Okay, so that's what we have at our disposal here in trying to prove these congruent. Okay, now in the first question over here, we're going to prove the triangle ABC is congruent to triangle DEF. Now it's very important here to make sure that we go in the right direction. So I start here at this vertex A, and then which is at one end of the hypotenuse, and I'm going across from here to the other end. So if I start here at this end over here, okay, and I would have to start at that end because that's the vertex that corresponds to A, then I have to go over here in relating the triangle. So I have to say A, okay, A, and then B over here, okay. So A, B, and C is going to be congruent to D and E and then F in that order, okay. So how can I prove these two triangles congruent? Well, I have right triangles here. So the only theorem here that has to do with right triangles is hypotenuse leg. Now this theorem says that if two right triangles, I have to be given that they are right triangles, and here we are given that they are right triangles. If two right triangles are such that their hypotenuse are congruent, like this, hypotenuse are congruent, and one of the legs is congruent, like this, one of the legs is congruent, then the two triangles are congruent. So we can use hypotenuse leg to prove these two triangles congruent. We have hypotenuse that's congruent, and we have one of the legs congruent. That's what that HL stands for, hypotenuse leg. Now, I just wanted to caution you that you don't always have to use hypotenuse leg to prove right triangles congruent, okay? There are times when you will use other methods of proving right triangles congruent other than hypotenuse leg, okay? So, we have another right triangle question over here. Let's call this question number 3. We can do this one next and see. So now we have two right triangles, right? And then here we can also prove that triangles, let's start with S, right? So we can say triangle SVR is congruent to triangle KVR. So KVR, we have to be again careful the sequence of the vertices of the triangle. So we start from this end and we're going towards the right angle. So we have to start at this end, we have to go towards the right angle, and then we end this way, and then so we go this way here. SVR corresponds to KVR. Now these two triangles are going to be congruent because, okay, now we have right triangles, so we'll see if we can use our hypotenuse leg. So can we? Because, okay, we have hypotenuse that's congruent, and we have one leg that's common to both of them. So RV is common to both of them by reflexive property, those two, right? So we have this triangle over here with hypotenuse and this triangle over here with hypotenuse and leg. So those two triangles will be congruent again because of hypotenuse leg. Okay, so this would be congruent because of hypotenuse leg as well. Okay, now I'm going to just label these first. I'm going to go 4, and then number 5, and then number 6 over here. So I'm going to then do number 2 over here. Now here we have two triangles as you can see, and we are going to prove that triangle, now you have to be careful, triangle PQR is going to be congruent. Now look at this. I'm going to start from this side, triangle P, and then I went to Q, and then I went to R, right? So if I were to figure out how to label this, I start from here, S, okay. Then I went to this orange side, right? Orange side, okay. I'm going to go this way. So it's going to be, we're going to have to put PQR is going to be congruent to SRQ. That's what we're going to prove. So we're going to prove that PQR is going to be congruent to triangle SRQ. Okay, now how? Well, if you look at these triangles, now there's only like, you know, 4 ways to do it, like side, 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 side angle, side angle, side angle, 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 side, right? So what do I have here? I have, it looks like an angle that's common to them. So this angle right here, okay, is congruent to this angle right there. Okay, that's angle. So that's an angle. And then I have this side right here is common to both of them. See, that side is shared. This side is shared by, like that side, ta-da, okay, is shared by both of the triangles, okay? Oopsie daisy. Okay, so that's side, angle, side, okay, and then I have, let's call this 2. So angle, side, and then I have this blue angle common. Okay, so that angle is congruent to this angle. So I have angle, side, angle. Okay, so these two triangles are congruent. Okay, angle, side, angle. Okay, so those two triangles are going to be congruent because of angle, side, angle. Okay. Now you also have to be very careful here. See, this angle corresponds to this angle over there. The triangles are like flipped, okay? And and this triangle, this angle corresponds to that angle over there. Now, if we wanted to say, okay, then we could say this side is going to be congruent to this side because of CPCTC, right? Okay, because those are the corresponding sides, and this side is going to be congruent to that side because of CPCTC, and this angle is going to be congruent to that angle because of CPCTC. Congruent parts of congruent triangles are triangle, but the way you would prove those two triangles congruent would be angle, side, angle. Okay, let's do number 4. Now we are to prove that triangle PSR is congruent to triangle QSR. Okay, so how are we going to do that? PSR, QSR. Well, I have an angle here. I have an angle here. Okay, so angle, side, angle, side, angle. But no, I don't know if those sides are congruent. I'm not given that. Okay, well, how about these angles? Are they congruent? No, I'm not told that they are. Okay, how about these? Are they congruent? I don't know. I'm not told that they are. Well, you observe that this side is common to both triangles. That's reflexive property RS, right? So now I have angle, angle, side. Is that legitimate? Angle, angle, side? Yes, it is. Angle, angle, side. So these two triangles are going to be congruent because of angle, angle, side. Okay, that's very good. Okay, number 5. Let's see what we got. Here I'm given these two triangles. I'm given this side is congruent to that side. Very good. And then I'm given this angle is congruent to that angle. Very good. Now what else? Okay. If I had this side congruent, then I would be this side, angle, side. But I don't have those two sides congruent. Okay. If I had these angles congruent, maybe they are, but I'm not told that, so that would be angle, side, angle, but they're not. Now what do I do here? Well, then I realize that these two angles are going to be congruent because they're vertical angles, vertical angle theorem. Then I have angle, angle, side, angle, angle, side. So those two are also going to be congruent because of angle, angle, side. So here we can say triangle ACE is congruent to triangle BDE. So ACE, BDE. You have to make sure you do it in the correct sequence. So okay, so we got those two triangles congruent. That was not so bad. Okay, and then number 6, I have these two triangles. I'm going to try to prove them. How can I have side, side? I bet you got this one already. That's third side, so that's reflexive property. So side, side, side will give these two triangles to be congruent. So that's triangle DBA is going to be congruent to triangle DBC. There we have it. So there we had some 6 questions of triangle congruence, and in the next session inshallah we shall do some that are slightly more challenging than these. Until then, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alamin. Assalamu alaikum.